Hello, everybody. Welcome to this session wherein we are explaining how the plot of impulse step and ramp functions can be done in Python. You all have the idea regarding this impulse step and ramp functions, how they look like, how we can plot them and all that. But we have not done that in Python. So let's try see how they look like in Python. Before we actually go into Python, I have told you before that we need to have this Python installed. Okay, I have provided you with those videos from which you can uh, see how to install Python and the packages required for the tasks given to you. The tasks given to you are the sinusoidal function needs to be plotted, okay, and different operations need to be performed on that. And now in the second video, we are seeing how to plot the impulse step and ramp functions. We refer to them in general as the basic signals in signals and systems. Fine. As you all know, and I have explained you, what is the first thing that we need to have does to uh, work with Python. We need to have packages first. Okay, we need to first install that along with Python, and after installing those packages, we need to import those packages in our program. So what are those packages we're looking at? So the packages are NumPy and Matplotlib, the same packages which we have imported when we were plotting sinusoidal signal in our previous video. Okay, the same packages are being imported here also because the task is again the same. There we have seen the sinusoidal signal. Here we are seeing the unit step, the unit ramp, the unit impulse. They're all signals only, and they are nothing but the numbers. Okay, so to deal with the numbers, we are importing NumPy package, and to plot the generated signals. Okay, so we have imported the Matplotlib package, or you can call them as libraries. Fine. Once we have these two, we have to define our x-axis. Fine. In the previous exercise, we had seen this different definition of x-axis by using what linspace, that is linear space, right? So for a change, let's see a substitute to that, that is arrange. Linspace is one way in which we can define our x-axis, okay, and arrange is another way of doing it. They have a small difference, okay, so I'll let you know what is the difference, okay, it has uh, by going into Python. Okay, so before that, just understand that this also is defining x-axis as we did in the previous case. There we define t. Here let's define n because we are particular about the discrete signal. So let's say we are going with n, not t. And what is the space? What is the length here? It's minus 10 to 20. Minus 10 to 20. Okay, it starts at minus 10 and ends at 20. So that is our discrete time axis n. Fine. And this is another function that is there in NumPy library, that is size. So what does it do? It will give you the size of this n. Okay, that is the x-axis what we have defined. Okay, how many points are there on that? Okay, so that can be seen using size. So that size of this n is being assigned to a variable L. Okay, L, that is length of the axis. Fine, it goes from minus 10 to 20. How many points are there from minus 10 to 20? Okay, is actually calculated by this np dot size. Okay, size is a function which is there in NumPy library, so we say it is np dot size. Without this np dot, if we just say size of n, it won't work unless we use the library. Okay, size has no definition. Fine, only within NumPy library size makes sense, otherwise size makes no sense to Python. Fine, so that size of n, okay, is stored in variable L. So L gives us the number of points on this particular space from minus 10 to 20. How many points we considering is what this particular L tells us. Fine. Now, before we actually go into Python programming, I would just like to give you a brief introduction regarding the impulse signal. What is an impulse signal? See, in discrete time, I'm telling you. In continuous time, you know, at n equal to 0, it is something that cannot be determined. Okay, it's infinite, we say, or something that cannot be determined. Fine. At n equal to 0, and it is 0 uh, for n not equal to 0. But in discrete time, it is 1. So what is it here? This is how the impulse step looks like. This is 1. So it is a sample of 1 at n equal to 0, right? It's sample of 1. See the y-axis. The maximum is 1 here. And see the x-axis. X-axis goes from minus 10 to 20. So that is what we saw here. We are arranging our x-axis to range from minus 10 to 20. That is what is visible here, minus 10 to 20. And in the scale of minus 10 to 20, where do you think your impulse signal should exist? It should exist at n equal to 0. So that is what is shown here. So delta of n, that is impulse function, is 1 at n equal to 0, and it is 0 for n not equal to 0. This is your impulse function or impulse signal. Understand that? It's called as unit impulse, to be precise. Okay, because it has the amplitude 1 at n equal to 0. Okay, so in discrete time it is amplitude 1, whereas in continuous time it is indeterminate. It cannot be determined. Okay, in continuous time. Fine. Now, how to get that impulse in Python has to be understood from these codes. Okay, now impulse, okay, the function impulse is being defined by this particular variable imp imp. Fine. Then np dot zeros l, what it is, what is the zeros? It's a function in numpy library. Zeros is a function in numpy library. What does it do? It makes all the points starting from minus 20 to, sorry, minus 10 to 20. We have these points, right? Minus 10 to 20. So all these points are made 0 to begin with. Fine. Then we take an index. Okay. Then we take an index. How the index is selected now? Though we have to select an index where we want the impulse to be 1. Where we want our impulse to be 1? We want our impulse to be 1 where n is equal to 0. Right? We have made all the points starting from minus 10 to 20 zeros. Okay. After we have made them zeros, now we select an index where I want the impulse to be 1. So where is that impulse? Where is that index where the impulse is going to be 1? It is at n equal to 0. So this is IND. You have to read it as index. This IMP is for impulse and this IND is for index. So how to select the index where we want the impulse to be 1? So that is selected by using where function. So there is a function called where in NumPy library, okay, which lets us select the numbers or the samples, okay, where we want the impulse to be 1. Okay, so which sample needs to be selected, which n needs to be selected. So select an index where n is 0. So this is what is the meaning of this. Fine. First, all the points ranging from minus 10 to 20 are made zeros. Then we are taking an index where n is 0. Fine. And in that index, see, impulse in that index where n is 0 is the meaning of this. Impulse, okay, impulse of index means this is impulse where the index is 0. Okay, so that needs to be made 1. See, that is what it is saying. So just read these comments, you will understand. I've told you in Python you can write comments by using this hash symbol. So what is it being done for the first instead of for the first line here? Impulse np dot zeros. Zeros is a function in NumPy library. Okay, and that is used to make the length n. That means whatever points you find how many points there will see, all those points are made 0 on x-axis. Fine. told here for the second line, index is where n equal to 0. You have to select that index where n equal to 0. Then impulse function in that index need to be made 1. So find where on the index of x-axis n equal to 0. Okay, so find where on the index of x-axis n is 0 and then make that index 1. Then you go for plotting. How do we plot? We say we use the function, we use PLT. PLT is what? PLT is a library for which we have, that this is the abbreviation we are using. For what? For what we are using this? Here, matplotlib is the library. For that, we are using this PLT. So matplotlib is being defined as PLT here in short. Okay, and stem is a function in matplotlib which lets us plot this impulse function versus the axis versus the x-axis, which is discrete points along x-axis, that is n. Fine. So this is what we are doing, and once we plot that, we can give the title to that plot. Fine, and we can label x-axis and y-axis, and we can define grid also. We have written false here. If you say false, okay, the grids will not appear there. If this false is made true, the grids will appear there. Okay, so this particular exercise we shall do for impulse, for generating the impulse function in Python now. Fine. I hope you have understood what I mean. Now, to make the things clear, I think so I'll just try explain this with some sketches. So let me do that now. Fine. Let me take this one note for that. So what it is telling us is, see here. First, you should understand we have this n x-axis wherein we have got points ranging from -10 to 20. Okay, that is this. See here, everybody. We have this x-axis, which is n. Fine. So it ranges from where to where? It ranges from -10 to +20. -10 to +20. Fine. So 0 comes somewhere here. This is -1. Fine. And this is 1, 2, 3 up to 20. This is how our x-axis is defined. And how many points do you have in this x-axis? Everybody understand here, from -10 to -1. Okay, how many points we have? We have 10 points, right? From, so it's not 20, it's not 20, sorry, since we have 0 here. Okay, so this actually is 19. So totally how many points we will have starting from 0 here? Starting from 0, we are going to have 20 points. So totally we have 30 points. Okay, so in this what is being done? So this is what, and size of n. So L is being assigned with size of n. So that means how many points are there from -10 to uh, uh, 19? Actually, there are 30 points. So the 30 points, the number 30 should come and sit in this L. So that is how the program has been written. Then what this is doing, it makes all of them zeros to begin with. So this particular statement will make every sample here 0 to begin with. Here, this is 0, this is 0. Every sample here is made 0 to begin with. Okay, so that is what is being told. It's 0 to begin with. Then what is there? You find an index where n equal to 0. Okay, and that you assign to index where n is equal to 0. So that is your index. So this is your 0. Yeah, so this is where the index is pointed now. Fine. So that index is being given. See, now impulse function in that particular index where n is 0, okay, is being made 1. So that means there will be a sample of amplitude 1 at this point. So this 0 will go now. In place of 0, you will have a sample of amplitude 1. Okay, so this is what is your delta of n, the impulse function, the unit impulse function at n equal to 0. Fine. So this is something that I want you to understand in Python. Okay, how to do this in Python is what I have explained you. Now we shall try demonstrate that using ideally platform. Fine. Now before we actually go into that, let's see. These are the libraries we have imported. Import NumPy as np, okay, and import matplotlib.pylab as plt. Fine. So these two are the libraries or the packages that we have to import. Then see, in NumPy we are using arrange. So before we write the whole program, we can run this, not a problem. Okay. So let's run. So before running, if we save it, it's good. Okay. So what you have to do, if you have not saved, you have to just go to file and save as. Save as and give it a proper name. What name we can give? Let's give it as impulse. Let's say impulse 1 because I already have a file by name impulse there. So let's make it as impulse. So we have saved it by name impulse. Okay. Now impulse 1 rather. Now let's run this. So nothing is coming there, but since we have not plotted anything in the code, there's nothing coming. So you can see what actually is T there. So in the command window, what you can do, you can just type T and press enter. See how many points are coming there? All these points are coming there, starting from -10 up to 19. I've explained why 19. Why 19? See here, we need -10 to 20. Right? We need totally 10. There the 0 is not taken care of. But here on the plot, the 0 would be taken care when we define the x-axis. Fine. So -10 to -1, it is 10. From 0 to 19, it is 20. That is how the definition is. Fine. Now, once we see that, let me just remove this. Yeah. Now, this is what we have. Now, let's see the size of it. There's something that happens. So let's see. Okay, np dot size of what? T. So it is 30. So that means you totally have 30 points. That is what is told here. 10 points here on the left hand side, the negative points, and the 20 points here on the right hand side from 0 to 19. So that is why it is being taken as 30. So the size of T is 30. Okay, so I hope you understand. Now let's try differentiate arrange from the what, the linear space we have seen in the previous video. Okay, so let's do that now here in Python only. We can do everything in command window, then we shall go to write the actual program. Fine. So let's say np dot linspace of, okay, now it goes from -10 to 20. Okay, so how should that be taken? The np dot arrange is there. In place of arrange, you need to have just linspace. Okay, let's see what happens now. So these many points are given. See what happened with arrange is this. What happened with arrange is this. It gave an array of 30 points. Okay, now in linspace, if we don't give anything, it takes 20 points. It takes by default 50 points. Okay, so let's see, let's define it as, let me take this, control C. I'll make my n equal to this. Okay, I'll run. Okay, now what is my n? So n is same. Fine, I'll now see the size of n. So I'll just take this, copy here, and I'll do control V. So I'm doing that. You can see that properly. Fine, I'll just press enter. See, the size is 30. The size of T is 30, but we want size of n, right? The size of n. So it is 50. By default, linspace give you 50 points, whereas by default, whatever is the space that we have defined, arrange gives us that. So minus 10 to 20, 30 points arrange will give, whereas the linspace will give by default 50 points. Fine. So by default, whatever we define, arrange gives us that, but linspace gives us 50 points by default. Okay, but now let's do this. Just see this, I'll tell you. Now again, let's take this linspace and okay, now we shall say we take 100 points here. Fine. Now let's say size of n. See, if we take 100 points, linspace gives us 100 points. So this is your linear space. Now let's do the same with what? Arrange. Okay, let me take arrange in place of linspace. I'll say that's T for you. Okay, in place of linspace, I'll say ARANG, arrange. Okay, I don't give this, but I give step size. See, 0.1, I'll say. What is the meaning of this? The meaning of this is, let me just show you. So 75 lines are there in this array. So why is it so happening? Because so there are 30 points. So 30 points into 10 is the meaning of this. That is 300 points it will give. Okay, the arrange will give 300 points if I say point size of the step size of 0.1. So let's say now np dot size size of t. Okay, so what it gives? It gives 300. See, if we give 0.1 step, it will give 300. If we give 100 in linspace, it will give 100 points. Okay, if we give 0.01 as the step size, okay, in arrange it gives us 300 points. Suppose if I go one more step smaller, what I do, yeah, I'll say this 0.01. If I say 0.01, from minus 10 to 20 we have 30. So 30 into 100, you will have 3000 points. So let's see size of t now. Here 3000 points. So it's all about in linspace. Understand, in linspace we say number of points that we want. Okay, so in arrange we define the step size. If this step size is smaller and smaller, better and better would be your what the plot. In linspace, if this number of points are bigger and bigger, then your plot is better. Okay, so that is the difference. Okay, this is where the difference lies between linspace and arrange. The first two arguments are the same from where to where it goes. In that range, how many points you have to consider is what the third argument is saying. Okay, whereas in arrange, the third argument says in which step size. If the step size is smaller and smaller, more and more points you get between that. Okay, so you can just work out that yourselves. Okay, now we shall go with this and see how to get our impulse function. Fine, there are too many things that you can explore. Fine, yourselves. but this is the difference that I wanted to give between linspace and arrange. Okay, both can be used interchangeably, but you just understand the third argument that comes there. Fine. If you don't give any argument here, it means the arrange just takes the 30 points. Fine. So that 30 points will be multiplied by 10 if you give 0.1 here. It will be multiplied by 100 if you give 0.1. So those many points it considers in that particular range. Okay, so let's not go for considering those small step size, because we are going with discrete signals. In discrete signals, if there are too many samples, the samples will get merged. So let's keep the sample size to be the size which this particular range takes, from -10 to 20. It has what? 30 points. So let's go with those 30 points. Fine. Now, what we need to do after that, let's go to this and just copy. Okay. So let's take the size of this. Fine. So the size of n would come and sit in L. So how many points you have there? You have 30 points. 30 will come and sit in L. Fine. Then we shall take this. So this I have explained. So what are we doing? We are trying to generate what? Impulse function. Fine. So here let's have that code. Fine. Impulse, first we make all the 30 points zeros by using zeros function in NumPy library. Then we find an index wherein n is 0, and in that index the impulse should be 1. Then we go for plotting. Fine. So how to define our x-axis, y-axis? Okay, is told here. Just take this and paste it over here. I'll anyways be providing these codes along with this video. You can make use of that. Fine. Now grid is also provided, x label is provided, y label is provided, the title is also given. Understand? We are not rather we can go for subplots as we have done in our previous video, or we can just go with the figures as figure 1, figure 2 with separate plots for each of these figures. Okay, I'll show you both the options when it comes to plotting. Fine. Now what we need to say, we have to plot, right? So let me just do that. File. So if you see this, you will understand. Okay, so plot.show is another thing that we should not forget. Fine. So let's have control plot.show. So we have to show that plot. Okay, so this is something that has to be there as our last line in every plot. Fine. So plot.show is something that we should not forget, otherwise it won't get plotted. Fine. Now let's run this program. See, now we have a function which is impulse signal here, and this impulse signal is 1 at n equal to 0. Fine. So this is how we can plot impulse signal. Now this is regarding impulse. Now how can we have a step? What is step? Step is having ones for n greater than or equal to 0. At 0 you have 1, at 1 you have 1. So from 0 to infinity you will have samples of 1. So how can we do that using the same type of code? It's almost the same. Okay, so let's try do that. So let's say let's generate what? Let's generate what step signal. Let's generate a step signal. Fine. Now you can just copy paste these codes. Fine. So there was no grid, I think, in this. There is no grid because here plot.grid is false. So if you make this true, okay, the grid will come. I'll run again. I'll just see here. Earlier run has no grid here because the grid plot.grid was false. Now I have made it true. Okay. So I'm running it now. So you have a figure with the grids. Okay, so with grids, it's better because you can see the values very clearly. Okay, so grid having a grid in the figure is always advantageous. Fine. Now let's just copy this code, what we have for impulse, and develop that code for step. Fine. So the impulse is being given the name IMP. Okay, so let's give the name STP for the step. Okay, here also first using the zero function, all the 30 points in this particular axis, x-axis, are made 0. Then we have to find the index where this step function has values 1. So where do you think the step function has got values 1? That I'll show you here. Yeah, this is impulse for you. Fine. Next we have the step signal. The step signal here, it's not 1 only at n equal to 0, but it is n for n greater than or equal to 0. Right? So u of n is the step signal, which is 1 for n greater than or equal to 0, and it is 0 for n less than 0. Fine. So this is what we are trying to generate now. So let's see that in Ideally platform. Fine. So this is step. Now we need to select the index, and index is where index is earlier at n equal to 0. Now index is for n greater than or equal to 0. So this is our index now. Okay. And in this index, this step which we have defined as STP should be 1. So STP in this particular index is what? Index is n greater than or equal to 0. Fine. In this index, let step be 1 is what we are saying. Then we just go for similar plotting of step as we have done it for impulse. Okay, it is impulse here. Let's make it as step, the title. Okay, the sample numbers n. Here also the sample numbers are n. Fine. This is amplitude, we can say, not a problem. Fine. So now this is ready now. Your step function is ready. One small adjustment that we have done is what? We have just selected the index as n greater than or equal to 0. Here the index is n equal to 0, whereas here the index is n greater than or equal to 0. Before we select the index, make every point 0. Then select the index where you need to change the values. Fine. So that is what we have done. Now let's run this program. So we are having just figure 1 for step. The figure 2 is not visible, so I have suppose you are going for plot here, right? You are going for plot. Fine. So here you need to say plot figure 2, where we need to say that before you go for plotting. So one plot is fine. So the first plot will come without saying that. The second plot dot figure figure 2 needs to be told that. Okay, because if you want to have both the figures out, okay, then you need to say that plot dot figure 2. So let's now run the water test. Yeah, now this is figure 1, which comes by default. We don't say plot dot figure for the first figure, so it just comes out as first figure by default. That is this. Yeah, it comes out as figure 1 by default. We don't call it as plot.figure 1. But for figure 2, we need to explicitly say plot.figure 2. Okay, so it comes as figure 2 now. This is your step signal. Everybody understand this? Okay, so this is how we can go for the step signal, which is 1 for n greater than or equal to that point. Now, in a similar way, we shall also plot our ramp signal. Okay, so let's do that here as our third signal. So that our ramp, R-A-M-P. So let's go for generating ramp now. Again, most of the things are the same. So let's just copy this, okay, and make the necessary modifications so that we can generate a ramp. Now, what is a ramp? Let me just give you the ramp details here. Here, this is our ramp. The ramp is 0 at n equal to 0, 1 at n equal to 1, 2 at n equal to 2, 5 at n equal to 5, 20 at n equal to 20. It has to go till infinity, but we have limited our upper limit to be 20 because we cannot go till infinity, okay, when we are plotting it on any platforms. So we limit it to some upper limit, right? So that is 20 here. So it is just showing us till 20. So whatever is n, the sample will take that value. That's why R of n, the ramp, is n for n greater than or equal to 0, and it is 0 for n less than 0. Okay, so let's see how to bring this particular function in Python. Fine, so let's go with Python ideally platform again. Okay, now what name we can give for impulse? We have given IMP. For step we have given STP. So for ramp we can give RMP. Okay, and here also let's make all the 30 points 0 to begin with. Fine, you have to select the same index as we have selected it for what the step function, because step function is also existing from uh, 0 to infinity, and ramp also exists from 0 to infinity. That's why the index is n greater than or equal to 0. So in the first two lines here, both are same except for the change in the name of the function. Understand that? So first all the points are made 0, then you have to select the uh, index where we need to give values to the function. Fine. Now step index is there, so we have to make the step as RMP. Okay, what should this ramp be now? I've told you, I've shown that to you here. The ramp should be n. Okay, the ramp should be n over what index we need to say. Okay, so that is where the thing is. So ramp has to be n. Okay, and it has to be n over what? It has to be n over the index that we have selected. What is the index? Index is n greater than or equal to 0. For n greater than or equal to, where index is n greater than or equal to 0, in that index the ramp should be n, is what is the meaning of this. Okay, and let this be our figure 3. Fine, what happens if we have that in figure 2? That can be seen. Okay, or let's make it 3. Let's have a separate figure for that. Fine, and this is not step, but this is RMP now, the ramp. Fine, the title, let's go as ramp here, and the step in the previous case has to be step 1. Yeah, the first one is impulse, the second one is step, the third one is ramp. The rest everything remains the same. I hope you understood this. What we are doing, the selection of index is same, but in the index that we have selected, let ramp be n. So how to say that? So our ramp is n in the index selected. That needs to be given here. Understand that? So impulse is n. Impulse is not impulse. This is something that you need to do now. What is that? This is ramp. Ramp is n for n greater than or equal to 0. And here what? Step is 1 for n greater than or equal to 0. But impulse is what? Impulse is 1 at n equal to 0. We have to give those comments. If you write the comments, okay, you can have better understanding of what we are doing. So have this habit of writing comments whenever you go for coding something. Fine. Now we have this the third figure in hand, and we need ramp to be plotted in that particular figure. That's our third figure. Fine. So let's run. Taking some time. Okay, fine. Now here, this is your figure 3 written there. This is your figure 2 step. This is your impulse. Fine. And this is your step as it has figure 2 name. This is your step. Fine. And this is your ramp. See, we have defined it till 20, so it comes till 20. At 0 it is 0, this is 1. At 1 it is 1, at 2 it is 2, at 3 it is 3, at 4 it is 4, at 5 it is 5. The grids will help you. See here, at n equal to 5, this is 5. So that is why it is called as unit ramp. It is called as unit ramp because the slope of this ramp is unity. Y by x. If you take delta y by delta x, that will give you unit slope. That's why this ramp is called as unit ramp. Fine. I hope you have understood the program. Okay. So anyways, I'm providing you with this program uh, in the comment section. Okay, or in the description. Fine. You can go through that and you can work on. Here, I have shown you how to have plots as different figures. Right. You can also do this program or plotting rather using plot functions. You can also have all these figures as subplots. In the same figure, they will come as subplots. Okay, so I have code for that. I'll just show you that. Okay, it's something that we have done in the previous case, so I'm showing you that here. See here, in this case, what I've done, I have taken the figure axis 1, axis 2, axis 3. So I have how many subplots there? I need 3 subplots. That's why I have ax1 to ax3, and it is 3 comma 1 means I have 3 rows and 1 column, and all the 3 figures will come one below the other as subplots. And why is this constrained layout true is there? This is there because yeah, in the subplots we need to have proper spacing between the subplots. Okay, so this particular thing will take care of that. Okay, just need to remember. Fine. So that is it. We have axis stem wherein we are plotting the impulse. Then we give the title x label, y label using the set command. Fine. Then we have grid. Fine. If you don't give anything, it means it's true. You can give true. See, writing true here or just not writing it means the same. Fine. If you write false, the grid will not come. That is how it is. In the previous case, we have written where is it? Yeah. In this case, we have written grid true, right? So plot grid true, plot grid true everywhere. Okay. So if you make this true as false, the grid will not be plotted. Okay. And if you don't write this true also, by default, it takes it as true. Fine. That is what is being shown here. So, but there we were saying plot, but since we are going with subplot, you have to say axis to plot 1, axis to plot 2, and axis to subplot 3. In first subplot, we are showing impulse. Second subplotted step. The third subplot is ramp. The code is same here. All the codes are same, but when it comes to plotting, So we have got all the three plots as subplots, one below the other in the same figure. So I'll just run this for you. And this is how it's happening. You'll have the subplots one below the other. Okay, in only one figure, figure one. In figure one only you have three subplots. In the previous example, what did we do? We had three separate figures as figure one, figure two, figure three for unit impulse, unit step, and unit ramp function. Okay, I hope the things are clear to you. I'll provide the code in the description of this video. Go through that, practice, you'll get good.